Hello dear students, and welcome to our second lecture concerning endocrine system, the biochemistry part. Today we're going to talk about the biochemistry and disorders of hormones of the hypothalamic and pituitary gland, what is known as the hypothalamus and pituitary axis. At the end of this lecture, we will be able to describe the structure and function of the hypothalamus, list the hormones secreted from the hypothalamus, outline how the hypothalamus controls the secretion of hormones of the pituitary glands, list the hormones secreted from the pituitary gland, state the peripheral effects of hormone release for each hormone synthesized or stored in the pituitary gland, state the peripheral effects of increased and decreased hormone release for each hormone synthesized or stored in the pituitary gland. Now, the hypothalamus is an integral part of the substance of the brain. It has a small cone-shaped structure projected downwards, ending in the pituitary stalk. The pituitary stalk is a tubular connection to the pituitary gland, which is a double-lobed structure that produces the endocrine secretions when stimulated by the hypothalamus. Many hormonal systems involved in the hypothalamus, and they are releasing hormone, and they are presented in the following table. As you can see here, this table shows the hormones that are secreted from the hypothalamus and affect the release of the hormones from the pituitary gland. These are called liberine hormones. And so they are thyrotropin releasing hormone, abbreviated as TRH, gonadotropin releasing hormone, corticotropic releasing hormone, growth hormone releasing hormone, prolactin release factor, somatostatin, which this is in fact an inhibitory hormone for growth hormone, and prolactin release inhibiting hormones, which are in fact dopamine and GAP. GAP stands for the gonadotropin releasing hormone associated peptide. Okay. And these, as you can see in front of you in the table, affect the corresponding hormones, the release of the corresponding hormone from the pituitary gland, and then from has their effects on the other end glands that are present in the axis. As we said, hormones of the hypothalamus affect the release of hormones, from the pituitary gland, and the pituitary gland, as we said, has two lobes. It occurs just beneath the hypothalamus, and it has two lobes. One of them is the anterior pituitary lobe, or the pituitary gland, and the other is the posterior pituitary. And other names are the adenohypothesis and the neurohypothesis. The neurohypothesis, in fact, it's considered as part of the hypothalamus because, in fact, they are axons from the neurons of the hypothalamus. The control of release, or the control of the hypothalamus on the pituitary gland, differs on على two lobes. So control of the anterior lobe, here the hypothalamus act as an endocrine gland that affect directly on the hypothalamus. Hormones are sent from the hypothalamus to the anterior pituitary via blood vessels. So these are blood vessels that carries the hormones from the hypothalamus to the pituitary gland. The target tissue is the anterior lobe of the pituitary gland. On the other hand, the control of the hypothalamus on the posterior lobe, هنا عندنا لو تلاحظون إنه الهرمونات which are synthesized in the hypothalamus they are directly released from the posterior pituitary lobe without any يعني blood connection. ما عندنا هنا blood vessels that carries these hormones. ليش؟ مثل ما قلنا because the posterior pituitary is considered as axons from the hypothalamus. So the hormones that are secreted from the posterior pituitary are in fact called neurohormones. They are synthesized in the hypothalamus and they are transported and stored in vesicles in the axons ending in the located pituitary, posterior pituitary gland. Nerve impulses travel down the axons into the posterior pituitary. This causes the release of the vesicles of the hormones into the bloodstream at the posterior pituitary. And we have two types of hormones, which are oxytocin and antidiuretic hormone. As is shown in this table, we could see here we have الهرمونات that are secreted from the anterior pituitary and from the posterior pituitary. لاحظ أنه posterior pituitary antidiuretic hormones and oxytocins they are called the neurohormones, and the major target organ antidiuretic hormone is the kidney while oxytocin is the ovaries. نجي على الهرمونات which are secreted from the anterior pituitary. A growth hormone. Major target organs are liver and adipose tissue. In fact, the receptors or target cells of the growth hormone are distributed in most parts of the body. Thyroid stimulating hormone, الريسبتورات مالتها located on the thyroid gland. Adrenocorticotropic hormone موجودة ريسبتوراتها على الادرينال جلاند and بالأخص الادرينال كورتكس. البرولاكتين على الميموري جلاند. Luteinizing hormone and follicle stimulating hormone ريسبتوراتها موجودة على الأوفري and or the testis. نجي هسه to discuss أول هرمونات اللي that is secreted from the pituitary gland, posterior pituitary gland, which is the antidiuretic hormone. الانتيدايريتيك هرمون أو الاسم الثاني مالته هو الفازوبريسين. Now the effect of antidiuretic hormone نلاحظ أنه طبعا بالمناسبة هذه الهرمونات which are secreted from the hypothalamus and pituitary, all of them are short peptides and proteins. The structure of the antidiuretic hormone is presented as you can see in front of you, and the effect of the antidiuretic hormone stimulate contraction of the muscles of the capillaries and arterioles, raising blood pressure, promotes contraction of the intestinal musculature, increasing peristalsis, stimulate water reabsorption by stimulating insertion of water channels or ما يسمى بالأكوابورينز into the membranes of kidney tubules. These channels transport solute-free water through tubular cells and back into blood, leading to a decrease in plasma osmolarity and increase in the osmolarity of urine. فمن هذا هو اسمه antidiuretic hormone. Okay? Control of antidiuretic hormone secretion. The most important variable regulating antidiuretic hormone secretion is plasma osmolarity, or the concentration of solutes in blood. When plasma osmolarity is below a certain threshold, the osmoreceptors are not activated and antidiuretic hormone secretion is suppressed. When osmolarity increases above the threshold, the ever alert osmoreceptors recognize this and stimulate the neurons that secrete antidiuretic hormone. As you can see in the figure, antidiuretic hormone concentration rises steeply and linearly with increasing plasma osmolarity, as you can see in the figure. The secretion of antidiuretic hormone is also stimulated by decreases in blood pressure and volume. Conditions sensed by stretch receptors in the heart and large arteries, changes in blood pressure and volume are not nearly as sensitive as stimulating with increased osmolarity, but nevertheless potent in severe conditions. For example, loss of 15 to 20% of blood volume by hemorrhage results in a massive secretion of antidiuretic hormone. Another potent stimulus of antidiuretic hormone is nausea and vomiting. Now, let's come to the disease status. The most common disease related to antidiuretic hormone is diabetes insipidus, and this condition can rise from either one of two situations: hypothalamic or ما يسمى بالcentral diabetes insipidus, and this results in deficiency in the secretion of the antidiuretic hormone from the posterior pituitary. Causes of this disease include head trauma, infection, or tumors involving the hypothalamus. Second, nephrogenic diabetes insipidus, and this occurs when the kidney is unable to respond to antidiuretic hormone. Most commonly, this results from some type of renal disease, but mutation in the antidiuretic hormone receptor gene or the gene encoding aquaporin 2 have been also demonstrated in affected humans. The major signs of either type of diabetes insipidus is excessive urine production. In some patients, they might even produce as much as 16 liters of urine per day. طبعا, of course, if adequate water is available for consumption, the disease is rarely life-threatening, but without holding water, this can be very dangerous and lead to dehydration. How do we confirm the diagnosis of diabetes insipidus? First of all, أول علامة هي diluted urine. Specific gravity مال urine أو specific gravity اللي هي الكثافة. النورمال يورين هو تقريبا من 1 إلى 1.01 إلى 1.02، بس لكن إذا قليلة كانت الكثافة مالت اليورين فمعناتها أن 3 احتمالات: either diabetes insipidus or glomerular nephritis or tubular damage. فشو نسوي الخطوة الثانية؟ هسه احنا أول شيء عرفنا اليورين السبيسيفيك جرافيتي مالته كانت كلش قليلة، عندنا 3 احتمالات. How could we exclude الاحتمالين يعني prove إنه diagnosis مالتنا is diabetes insipidus؟ نسوي ما يسمى بالwater deprivation test. Now, this test helps determine whether diabetes insipidus is caused by one of the following. الwater deprivation test احنا نمنع المريض من انه يشرب مي لفترة معينة من الزمن and نراقب الوزن مالته لانه يروح يصير عنده dehydration, severe dehydration and might be life threatening. Of course طبعا water deprivation test helps determine اللي هذه هل polyurination is due to excessive intake of fluid or a defect in the antidiuretic hormone production or defect in the kidney response to antidiuretic hormone. فهذه ثاني خطوة نسوي الwater deprivation test على مود نشوف إنه هل كان هذا المريض اللي دا يصير عنده polyurination هل هو excessive drinker, water drinker. فإذا سوينا الwater deprivation test رح نبعد عن هذا يعني هالاحتمالية. فيبقى عندنا حالتين: either central diabetes insipidus, central antidiuretic hormone disorder or nephrogenic. الخطوة الثالثة this test طبعا of course the water deprivation test measures changes in body weight, urine output and urine consumption when fluids are withheld. نجي هسه نقيس الانتيدايريتيك هرمون at the end of the water deprivation test. المفروض after water deprivation test بالحالات الطبيعية يعني during thirst مثل ما شفنا بالفيجر الانتيدايريتيك هرمون إذا كان طبيعي والهايبوثالاموس كانت طبيعية فيصير عندنا steep release or steep increase in the concentration of the antidiuretic hormone. إذا قسنا بعد هذا إذا قسنا الفازوبريسين وشفناه قليل معناتها this is central diabetes insipidus الكوز مالتها. إذا قسناها وشفناه عالي ويعني عالي نسبة إلى البلازما أوزمولاريتي مالت البلاد كلش عالية فمعناتها this is nephrogenic. وطبعا بعدها الكونديشن هي persistent مالت البوليورينيشن معناتها السبب هو nephrogenic diabetes insipidus أو لازم عاد نشوف يعني in this case we know how can we manage. لازم نعرف إنه إذا كانت central شلون how can we manage or إذا كان nephrogenic how can we manage. Okay. الهرمون الثاني that is secreted from the posterior pituitary gland is the oxytocin. And the control of oxytocin secretion, as you can see in front of you, is also 9 amino acid peptide hormone. The control of oxytocin secretion, number of factors can inhibit oxytocin release. Among them is acute stress. For example, oxytocin neurons are released by catecholamines, which are released from the adrenal gland in response to many types of stress, including fright. So these were the two hormones that are secreted from the posterior pituitary gland. These are called the neurohormones. In fact, they are, as we said, they are synthesized in the hypothalamus and secreted from the posterior pituitary, which is considered as exons of the hypothalamus. Now, let's come to the hormones which are secreted from the anterior pituitary gland, and these are hormones that are secreted from endocrine glands. Let's start or begin with the growth hormone. Now, growth hormone, another name of it is somatotropin, is a protein hormone of about 191 amino acids and is synthesized and secreted by cells called somatotrophs in the anterior pituitary. It is secreted in a pulsatile matter during daytime. Its plasma concentration in healthy adults remain relatively low, with several secondary spikes occurring after meals or exercise. And however, it shows marked rise in the evening in both adults and children and can reach a peak of value during periods of deep sleep. It's major participant control of several complex physiological processes, including growth and metabolism, and it is considered as an interesting drug used in both human and animals. The physiological effect it has both effects. Direct effect are the results of binding of growth hormone to its receptor on the target cells. بالأخص على الفات, adipose tissue, for example, have growth hormone receptors, and growth hormone stimulate them to break down triglycerides and suppresses their ability to take up and accumulate circulating lipids, leading highly direct effect. والindirect effect through ما يسمى بالsomatomedin, which is insulin-like growth factor. And this hormone is secreted from the liver in response to growth hormone. This majority of the effect of growth hormone is through insulin-like growth factor. And it appears to be the key player in muscle growth, as you can see in the figure, muscle growth and bone growth. Okay. It also has a certain هاي طبعا على growth وعلى metabolism. It has effect on protein metabolism, stimulate protein anabolism in many tissues. This effect reflects increased amino acid uptake, increased protein synthesis, and decreased oxidation of proteins. It also has effect on fat metabolism, utilization of fat by stimulating triglyceride breakdown. On carbohydrate metabolism, growth hormone is one of the battery of hormones that serves to maintain blood glucose. It is called an counter-regulatory hormones. It opposes the action of insulin. Okay. نجي على control of growth hormone secretion. لاحظ this is the axis of growth hormone secretion from the hypothalamus and growth hormone releasing hormone that is secreted from the hypothalamus and stimulate the secretion of growth hormone from the pituitary gland, as you can see. Pituitary then secretes growth hormone. طبعا الريسبتورات مال growth hormone distributed widely in the body, بس لكن أكثر شيء هو الليفر اللي هو indirect effect that will produce insulin like growth factor, وهذا الانسولين like growth factor اللي حيسوي لنا negative ما يسمى بالنيجاتيف feedback inhibition للgrowth hormone و positive feedback stimulation of somatostatin. Somatostatin is a hormone from the hypothalamus that inhibit the secretion of growth hormone from the pituitary gland, as you can see here. Another stimuli of growth hormone, and also it's a good appetite controller, is ghrelin that comes from the stomach. It has also a significant control of growth hormone secretion from the pituitary gland. Disease status. A deficiency state can results not only from a deficiency in production of the hormone, but also in the target cell response to the hormone. Clinically, deficiency in growth hormone or receptor defects are known as growth retardation or dwarfism. هذه الدورفيزم شوية تختلف عن cretinism. Dwarfism هو just short stature. Cretinism هو short stature with mental retardation, and it's due to hypothyroidism in children. And the effect of excessive secretion of growth hormone is also very dependent on the age of the onset and seen as two distinctive disorders, either gigantism. هذه تحصل عند الأطفال إذا صار عندنا excessive growth hormone secretion that begins in young children or adolescent. It's very rare disorder, usually resulting from tumor of the somatotrophs. Acromegaly results from excessive secretion of growth hormone in adults. Now, an excessive growth hormone and insulin-like growth factor also lead to metabolic derangement, including glucose intolerance. وطبعا هاي إن شاء الله تاخذوها أكثر وتتعرفون عليها أكثر بالdisease status بالديسوردرز مالت الهرمونز. الهرمون الثاني اللي هو الثايرويد ستيميليتنج هرمون. Thyroid stimulating hormone, also known as thyrotropin, is secreted from cells in the anterior pituitary gland called thyrotrophs and finds its receptors on the epithelial cells in the thyroid gland and stimulate that gland to synthesize and release thyroid hormones. TSH is a glycoprotein hormone composed of two subunits which are non-covalently bound to one another, as you can see in the figure.
It's 2:30.
The alpha subunit of TSH is also present in two other pituitary hormones, which are the LH and the FSH. TSH is composed of alpha subunit bound to the TSH beta subunit, and this is the one that is associated with the TSH receptor. TSH have several acute effects on the thyroid function. These occur in minutes and involve increase of all phases of the T3 and T4 biosynthesis. TSH also has several chronic effects on the thyroid. These require several days and include increase in the synthesis of proteins, phospholipids, nucleic acids, and in the size and the number of the thyroid cells. An important controller of the thyroid stimulating hormone is thyrotropin releasing hormone from the hypothalamus, and TSH is inhibited by high blood levels of thyroid hormones اللي هي هذه يسموها classical negative feedback inhibition. The third hormone is the adrenocorticotropic hormone, And this stimulates the adrenal cortex by enhancing the conversion of cortisol to pregnenolone. More specifically, it stimulates the secretion of glucocorticoids, which is or such as cortisol, and it has, however, it has little control over the secretion of aldosterone, which is the other major steroid hormone from the adrenal cortex. It is, as you can see in front of you, it is released from the pituitary gland in response to the hypothalamus hormone, which is the corticotropic releasing hormone, and this hormone is secreted in response to stress. So it's by far the most prominent. Cortisol is the most prominent hormone known as stress hormone. It is controlled also by negative feedback inhibition of cortisol اللي يأثر على inhibits الcorticotropic releasing hormone and the ACTH. وإن شاء الله تاخذون disease status when you will study adrenal cortex hormones of the adrenal cortex. Now, within the pituitary gland, ACTH is produced in a process that also generates several other hormones. The parent molecule that produces this hormone with the other hormones are called pro-opiomelanocortin, POMC, and it is synthesized and proteolytically cleaved into several fragments. One of them is the ACTH, the other is beta endorphins or beta melanocyte stimulating hormone, amino terminal fragment, other fragments that also work as hormones. The fourth hormone is prolactin, and prolactin is a single-chain protein hormone closely related to growth hormone. It is secreted from so-called lactotrophs in the anterior pituitary, and also it is synthesized and secreted by a broad range of other cells in the body. It contains 199 amino acids and has 3 intramolecular disulfide bridges. It also has an effect on the immune system, and it is important in the control of osmolarity and various events, including metabolic subcutaneous fat, carbohydrate metabolism, calcium and vitamin D metabolism, fetal lung development, and steroidogenesis. الكنترول of prolactin secretion from the pituitary gland بالحقيقة هي شوية البرولاكتين يختلف عن باقي الهرمونات. All hormones which are secreted from the pituitary gland are subjected to stimulus signals coming from the hypothalamus. فقط البرولاكتين لا، يعني it has no stimuli, it only has a suppressor اللي هو الدوبامين. and وسووا تجربة، يعني العلماء سووا تجربة وقصوا they cut off the pituitary stalk, and what they found that the pituitary stalk that is between the hypothalamus and pituitary gland, what they found that all the hormones which are secreted from the pituitary gland were suppressed, only dopamine continued to be secreted. So dopamine has no stimuli, it just has a suppressor, which is prolactin has no stimuli, it just has a suppressor, which is dopamine. Dopamine serves as a major prolactin inhibiting factor or brake on prolactin secretion. Prolactin binds to its receptors on the cell membrane of its target organs اللي هي البريست, adrenal, ovaries, testes, prostate, kidney, and liver, but with unknown intracellular mechanism. The fifth hormone, which is gonadotropins, اللي هو luteinizing hormone and follicle stimulating hormones, and these are called gonadotropins because stimulate the gonads in males, the testes, and the females, the ovaries. As described in the thyroid stimulating hormone, LH and FSH are large glycoproteins composed of alpha and beta subunits. The alpha subunit is identical in all of these 3 anterior pituitary hormones, while the beta subunit is unique for each hormone. Luteinizing hormone in both sexes stimulate secretion of sex steroids from the gonads. In the testes, stimulate the synthesis and secretion of testosterone. The ovaries respond to LH stimulation by secretion of testosterone, which is converted into estrogen by adjacent granulosa cells. Luteinizing hormone is required for the control and development and function of corporal lutea. The name luteinizing hormone derived from its effect of inducing luteinization of ovarian follicles. On the other hand, follicle stimulating hormone stimulate the maturation of ovarian follicles. It is also critical for sperm production. It supports the function of seroty cells, which in turn supports many aspects of sperm cell maturation. And the control of gonadotropin secretion is presented as you can see in this figure. طبعا it's much more complicated than that, بس لكن هي توضح لنا انه يعني negative feedback inhibition of LH and FSH by steroid hormones, and that will inhibit LH, FSH and gonadotropin releasing hormones. Abnormalities, alteration caused by compression or infarction of the pituitary gland. In general, abnormalities of the pituitary gland induce endocrine secretion abnormality. Pituitary tumors are seldom malignant or metastatic, but problems may be caused by the limited space as tumor growth and compresses within the sella torsica, resulting in excessive hormonal secretion or death of pituitary cells. As you can see in this figure, هذه هي pituitary gland, and this is the sella torsica. إذا صارت أكبر من اللازم، أكبر من pituitary gland, this will cause accumulation of fluid, cerebrospinal fluid, and this will cause compression of the pituitary gland, causing certain damage or trauma to the pituitary gland. أمثلة على examples of excess or deficient secretion, for example growth hormone deficiencies. طبعا يعني هاي اللي تسبب لنا pituitary dwarfism، يعني absence of growth hormone، وطبعا وأيضا يعني accompanied by decreased insulin-like growth factor secretion. راح يصير عندنا impaired normal development of bone and cartilage، خاصة إذا كان عندنا بالصغار. Testing of growth hormone deficiency include measuring of growth hormone levels. طبعا of course after using growth hormone stimulation، بس لكن هاي شوية صعبة لأنه مثل ما قلت لحضراتكم الجروث هرمون is secreted in a pulsatile manner، فإحنا أكثر شيء نروح على الانسولين like growth factor. Drugs that mimic either growth hormone action اللي هو somatotropin or growth hormone releasing hormone may be given in growth hormone deficiency disorders. Laron syndrome, although not a pituitary disorder per se، لكن إنه يصير insensitivity of الريسبتورات and lack of stimulation of insulin-like growth factor. فبالتالي there is no response to growth hormone, neither to insulin-like growth factor, and this is caused by an autosomal recessive gene that will cause dwarfism. إذا صار عندنا excess للgrowth hormone secretion، فشنو الناتج؟ طبعا excessive growth hormone induces hypersecretion of target tissues, insulin-like growth factor, which induces the classic features of bone overgrowth in the skull and mandible causing acromegaly and gigantism. مثل ما قلنا بالgigantism عندنا in children دول يصير عندهم epiphyseal plates are not closed, and so this may lead to overgrowth of the longitudinal growth of bone, leading to gigantism due to insulin-like growth factor stimulation, elongation and continued growth of long bones. Testing مالت growth hormone alteration includes glucose suppression. احنا قلنا انه الجروث هرمون هو opposes the action of insulin، فمعناتها يعني it's a counter regulatory هرمون، فمعناتها أنا إذا أنطي جلوكوز راح يصير عندي suppression بالجروث هرمون، فأسميه الجلوكوز suppression test. أنطي كمية معينة من الجلوكوز واشوف الريسبونس اللي هذه اللي هالجلوكوز يسموه جلوكوز سبريشن تيست. طبعا اكو بروتوكولات خاصه يعتمدوها بالمختبرات. طبعا of course الجلوكوز suppression test because growth hormone is decreased by increased glucose level ونشوف انه is it subjected to هال suppression or لا. Synthetic growth hormone inhibitory hormone that are similar to the normal growth hormone inhibitor somatostatin are used also in patients with growth hormone excess like gigantism or acromegaly. إن how to confirm the diagnosis مثل ما قلنا random growth hormone testing is not helpful. بس لكن إحنا شو نسوي؟ growth hormone مثل ما قلنا is usually decreased with glucose. So نعطي نسوي له التستنج اللي هو growth اللي هو جلوكوز يعني inhibitory testing. نعطي 75 غرام of sugar بجلاس مال مي ونخليه يشربه. بعدين وراها نسوي الميجرمنت مالت الجروث هرمون. أول ما ننطيه، بعدين ورا نص ساعة، بعدين ورا 60 دقيقة، بعدين ورا 90 دقيقة، ونشوف الريت مالت الكونسنتريشن مالته شلون. If growth hormone failed to be suppressed، إذا ما تأثر الجروث هرمون then the diagnosis of acromegaly is confirmed. بمعنى أنه if it was not subjected to any stimuli معناتها هذا secretion hypersecretion there is a hypersecretion of growth hormone which is not subjected to any stimuli. So that this is a confirmed test of acromegaly. Vast majority تقريبا 99% of cases of acromegaly are due to pituitary tumors. If a pituitary tumor is not seen in the MRI scanning yet acromegaly is confirmed, growth hormone releasing hormone level should be requested على مود نشوف انه شقد يعني القيمة مالته. To exclude ectopic production of this polypeptide by non-pituitary tumors. يعني قد يكون إذا ما شفنا tumor بالpituitary gland قد يكون ectopic tumor either in the lung or anywhere else that releases growth hormone. Pituitary adenoma. The majority of pituitary adenomas produce one or more of the anterior pituitary hormones. For example, prolactinomas are the most common pituitary tumor. Pituitary growth hormone abnormalities may be induced by somatotrophs adenoma of the pituitary, which produces increased growth hormone secretion and causes acromegaly. In conditions such as corticotrophs adenoma, pituitary hypersecretion of ACTH induces increased adrenal cortisol and mineralocorticoids levels causing Cushing disease with hypertension, central fat deposition and moon phases as well as glucose intolerance. فملاحظة جدا مهمة على disease versus syndrome. Cushing disease versus Cushing syndrome. Cushing disease is the result of pituitary tumor secreting inappropriate ACTH, while Cushing syndrome causes the same symptoms بس لكن المشكلة هنا is caused by overproduction of adrenal hormone اللي هو الكورتيزول. فالsyndrome is due to overproduction of الادرينال cortex, while الديزيز هو الأصلي اللي هو البرايمري cause مالتنا هو البيتويتري adenomas. So a disease increased cortisol from the pituitary بس syndrome هي other causes. This increase in ACTH stimulation may also induce hypersecretion of adrenal androgens with feminization effects in males. Gonadotropins adenomas produce abnormal gonadotropins and prolactinomas secrete prolactin, which induces milk production from breast اللي هو يعني المصطلح مالته galacturia. Pituitary adenomas rarely produce high levels of TSH. Which induces hyperthyroidism and goiter. عادة هو التريتمنت usually transphenoid surgery for the removal of the tumor with replacement of necessary hormones. هذا الشيت بس فقط يوضح لنا الأحجام مالت البيتويتري أدينوماز. عندنا المايكرو وعندنا الماكرو. الماكرو اللي هي أكثر من 10 ملم compression of the surrounding structures. In conclusion, the hypothalamus is a small cone-shaped structure part of the brain. It projects downwards, ending in the pituitary stalk. Pituitary gland, a roundish organ that lies immediately beneath the hypothalamus, composed of two distinctive parts, anterior pituitary adenohypophysis and the posterior pituitary neurohypophysis. The hypothalamus controls the secretion of hormones from each lobe of the pituitary slightly differently. Knowledge of hormone structure and the ability to synthesize specific hormones permit the diagnosis of the disease status and disorders. Thank you very much.